All right, so there was a guy, Mr. Boyle, who discovered the relationship between volume and pressure when he was dealing with gases. Kind of like we have seen with our marshmallow in the syringe or the shaving cream in the glass, bell jar. So with Boyle's law, what are we holding constant? This is showing volume and pressure changing. Well, then what's constant? What are we not changing? Temperature. So the constants are temperature, and we'll call that T. What else are we not changing? Brian? The number of particles. Yeah, the amount of particles.
Wait, do we put the paper in our notebook?
Yeah. Put the paper in your notebook, yeah. So the number of particles, we're going to represent the number of particles with a lowercase n. So, in math, it's like x and y are the variables. Often in science and engineering, it's n and m. N is usually the number of something. So the number of particles we're not changing here. We're holding them constant. And temperature. Now let's look here at our little beakers. Notice it says at the bottom under the beaker, pressure in millimeters mercury. Millimeters mercury, what is that a unit of? Temperature? No. It's pressure. So this is a unit of pressure. Millimeters mercury. Remember how it's almost like that blue candle experiment? The gentleman had mercury in a dish, just like that blue water, and as the air pressure changed, it pushed it up the burette, the millimeter stick, that was like a tube, pushed it up or pushed it down, depending on the air pressure, just like that. Yeah. So millimeters mercury is a unit of pressure. Let's remind ourselves of other units of pressure. Other units of pressure are kilopascals. Torr. That's a new one. We haven't heard of torr. By the way, T-O-R-R. It'll be on tonight's homework. It is a unit of pressure. We sometimes see ATM. And occasionally we'll see PSI, since we're in the United States, pounds per square inch. So those are probably the most common units of pressure. So I just wanted to remind you of those. So let's look at this first scenario. Oh, do you need me to keep that there? Let's look at the first scenario of our beaker number 1. Beaker number 1, we've got 10 millimeters mercury. We've got pressure on there. Let's say the volume of the gas is right up here at 100. It's at 100 milliliters. This right here is your pressure 1. This right here is your volume 1. If I change to the pressure, so here's our new pressure, pressure 2. Do you need me to invite someone? They're both absent. Okay. So here's our new pressure. I guess the question is, what's going to happen to our volume? So let's go ahead. On the bottom of your page, there's some room. Pressure 1 was 10 millimeters mercury. Our volume 1 was 100 milliliters. Our pressure 2 that we changed was now, we increased the pressure to 20 millimeters mercury, and now we want to know about volume 2. So what we're going to do is we're going to use Boyle's law, which is P1 V1 equals P2 V2. What's happening between those two variables? What mathematical operation? When you have two, multiplication. Okay, just wanted to remind us it's multiplication. When we plug in values, we always use parentheses. You can like overuse parentheses, it's fine. So P1 is 10, and we always use our units, millimeters mercury, times volume 1, 100 milliliters, equals our pressure 2, which is 20 millimeters mercury, times, oh, that's what we're looking for, a new volume. Okay, put your algebra hat on real quick. If I'm trying to get V2 by itself, I'm trying to simplify this equation now. I want to divide. Good, I'm going to divide both sides by 20 millimeters mercury. Now watch how I cancel. 20 over 20 cancels itself out, right? That's just 1. Millimeters mercury divided by millimeters mercury also cancels itself out. Look on the left-hand side. Is there anything I can cancel? The V2 is now by itself on the right. On the left side, the millimeters mercury can cancel. So I can go ahead and cancel my units of pressure. I'll be left in units of milliliters, by the way. Milliliters is a unit of volume. That's what I'm looking for. I'm looking for volume. Now let's do the math. 10 times 100 divided by 20. Or actually, let's just reduce 10 and 20. We'll say that's 1, that's 2. By the way, this is being recorded and going to all students. So your voice in the background, it's being heard. Just letting you know. So 100 divided by 2 is 50 milliliters is the new volume. Real quick, we have to think about sig figs. 10, 100, and 20 are all ambiguous numbers. So we have to go with the least amount of sig figs, and all of them happen to have only one sig fig. And therefore, our answer needs to be in one sig fig, and it naturally ended up being that way, so we lucked out. And we always box our answers. Now let's go and fill in our beaker with 50 milliliters. So go back up top and fill your beaker only to 50. The second beaker, because now that's P2. When we double, notice the trend. We doubled the pressure. What did we do to the volume? Cut it in half. Good. If we double the pressure, we cut the volume in half. I'm going to go ahead and move up top here. I doubled the pressure. I cut the volume in half. So without even doing the math, if I triple the pressure, what am I going to do to the volume? It'll be a third. Good. It'll be a third. It'll be around here. Oops, that's an eraser. It'll be around here. Right? Triple the pressure, it would be a third. So our volume here would be about 33.33. It'd be a third, although that's not proper sig figs, just pointing that out. But I would like to have the raw numbers right now so you can see the pattern. So, all right, we've quadrupled. Right now we have 40 millimeters mercury. We've quadrupled it. What are we going to do to the volume? Divide it by 4. Good. We're going to have 25%. So that'll be about there. So as we increase pressure, we decrease volume, or vice versa. That is the relationship with Boyle's law. I'm going to hand you out your homework, and we're going to do the first problem together. So I gave you more. All right, so let's go ahead and look at our very first problem. So we're looking at number 1 here. Okay, number 1. A sample of oxygen gas occupies a volume of 250 milliliters. Milliliters, what type of unit is that? Volume. Watch what I'm doing. I'm annotating. At 740 torr. What is torr a unit of?
Pressure.
Oh, okay, so here's my V1, P1. Look, I'm kind of lazy. I'm not even going to write it out. I'm just going to use this. Here's my V1. Here's my P1. It says, what volume? What is a question word? So I am looking for volume. Here's what I'm looking for. Will it occupy at 800 torr pressure? Okay, this must be my change in pressure, my new P2. So I just annotated. If you notice, I have a V1, a P1, a P2. What I don't have here is a V2. This is what we're looking for. So let's go ahead and plug it into the formula. P1 is 740 torr. Notice the little decimal means that it has 3 sig figs. Let's do that now. And our V1 is 250 milliliters. 3 sig figs there. And then our P2 is 800 torr. Happens to have 3 sig figs here because of all these decimals, times V2. So I simply will do like I did before. I'm going to divide both sides. Sorry, it's running into the problem below. 800 torr. I'm going to divide by 800 torr. My torrs cancel. And if I do that math, my V2 equals 231.25. What are my units? Well, my torrs have canceled, so I'm units of milliliters. How many sig figs should my answer be? 3. So I need to round to here. So I look at the 2. Therefore, it keeps it the same. So my answer is just 231 milliliters. And please put your answers on this line here. That way it's nice and easy to grade. Now, if you notice how I made a mess and I was like, didn't have enough room, if you want to use a separate binder paper, you're more than welcome. But I strongly urge you guys to annotate, or if you actually wanted to write it all out, kind of like I did before at the bottom of the notes, you can write V1 equals, P2 equal, right? You can write down all the variables. They're going to be, our first quiz is going to be on Boyles' Law. When? What's tomorrow? Thursday.
I thought we already had our
First quiz on gas laws. I don't know, I have to think about it. I might throw it at you tomorrow, but remember, I always take you a second time. I might give it to you with some other ones too, but there will be quizzes on this, okay? So please make sure you do your homework. Go be the change that we want to see.
I got you.
Right? Don't bite on the social media bait. And be nice. Be kind. Be nice. Doesn't cost you anything. No.